So in this class, we will discuss about global and local variable scope, where we will talk about how exactly we define the global variables and local variables and how we use it. Then we will be discussing on inner functions and closures. And these are some couple of advanced topics of function. We'll cover recursion in detail, where a function that calls itself to solve a problem. Then we will be discussing on decorators, how we create the decorators, how we use the decorators. And decorator is the one of the most important topic for building any application. Either if you are building a web application or AIML applications, there are many places where we use decorators. So if you see here, the commonly used for decorators are logging, access control, memoization. We'll see those kind of questions and we'll discuss that. And at the end of this session, we will be discussing on interview questions. I'll give some assignments to you so you can solve that. So before moving to global versus local variable scope, you complete this quiz. And this quiz is having 10 questions. Each question is having 4 options and one option is correct. So you solve it. And this will give you the more confidence from previous video. The link of this quiz is attached into comment. So now let's move to global versus local variable scope. Global variables are defined outside of functions and can be accessed anywhere in the code. Means, let's say if I define a variable which is outside of the function, we have, let's say, def func1. This is one of the function. Values passed as of now here. Maybe I'll print something. Print. This is f1. And now I have a function 2. This is function 2. And we have function 3. This is function 3. So we have 3 functions now. So the thing is, whenever you define a global variable, you define it outside of the function. So let's say one of the variable is count. So count equals to 0 now. Now what is the benefit of using a global variables? The data can be shared among the functions. So function 1, function 2 and function 3 can share the data, like can share the variable. So let's say you can access this count here, print count. Similarly in F2 also you can access it. So if I call function 1 F1 and function 2 for the execution, then it returns the output like this. So we are able to access count value within both the functions. Now the advantage of having a global variable is you can change the value at one place. So let's say you have certain constant, some config constant, or you are writing an web application. There are certain configurations like backend URL or database URL, right? Or there can be couple of environment variables also which we are configuring. So it's up to you. We use it those as a global variables. So let's say one constant is here. We can say um let's say flag. Flag is true, or I can make it DB flag maybe. So what it does, this DB flag is true. So based on the DB flag, I can take a call in function 1. Either I need to call the database or not. For example, let's say if I write the condition if DB flag, if DB flag, then let's say print connecting to database. So the same DB flag we can use here also, or in function 3, if DB flag then fetching data from database. Right? So you can define the constant outside of the all functions, and these variables can be shared across the functions. So now the advantage is you will be changing at once and it will reflect anywhere. So let's say right now the count is 0. Now if I make it 10 here, then it will reflect everywhere. So I'll not change, I'll not go inside the function and then I'll change it. So that is one of the advantage. So now let's suppose if you want to change the value of global variable within the function, you can do that. But that is not the best practice. You avoid to change the value of global variable within the function. So how you can do that? So you can access like this global, let's say db flag, and then you can say db flag equal to false. So here we are doing intentionally changing the value. And now if I run this program, see the output. So for function 1, this is function 2 and function 3. So now what happens is I'm executing function 1 where in starting the value of db flag was true. Now because function 1 got executed first and I accessed this value using global keyword and I changed it to false. So in both the function 1, this statement also will not execute because db flag now false. And in function 3, this also will not execute because we have changed the value of db flag. So this is how you can change or you can update the value of global variables within the functions. So the idea is if you are not using global keyword, it means you are creating a new variable within the function and using that function instead of global. So now what happens is, let's say I changed db flag to false here. So this statement will not execute because db flag value is false. But when it comes to function 3, and if I run it, you see the output fetching data from database. It means db flag is true. So this db flag variable is your global variable and this db flag is your local variable. So that is the reason why we have used global keyword here. So we are externally saying to the compiler, use this variable instead of local or creating a new variable. So now how the local variable works. So let's suppose you have a function 1, function 2 and function 3. We can say 3 functions. So I'll define it here. Let's say def function 1, and this is the place where we define any variable. So if you are defining any variable within the function, let's say the variable name is x equals to 10, y equals to 20, and then you have another def function 2, and here if you have couple of variables, let's say a is a1, b is 2, so like that. And again you have another function def function 3. So in this block we are initializing couple of variables, maybe name equal to Rohan. So these are the local variables within that function. So this is local variable for function 1. These are the local variables for function 2. So the meaning is, let's say if I am defining any variable outside of it, count equals to 0. This will become a global variable because we are defining outside the block. If we are initializing any variable within the block, these variables called local variables. You cannot access this variable into function 2, or you cannot access y variable into function 3. You cannot share among. How you can do it? You can return x from here and then call function 1 here and get it. That is one of the way, but that doesn't mean we are making this variable as global. So whatever variable you are defining within this block is called local variables, and this is global variable. So count can be accessed here, count we can access here also and here also, because of this is global variable. So that is the difference between local variable and global variables. So let's see, we'll create couple of variables in function 1. Here let's say x equals to 10 and y equals to 20. So if we print it here, definitely it is gonna work. But in function 2, if we will say print x comma y, then function 2 will give an error. Why? Because the variable x and y are initialized within function 1. So these are the local variables for function 1. So you will not be able to access into function 2. What you can do is you can make it global. So if you want to make it a global, you can do it. Global x and global y. So then it will work. So it's up to you how you're using it. If you are not making it global and initializing only, then you cannot access local variables into other functions. So let's say here I'll create a equal to 1, b is 2, then I'll print a comma b. So a and b are local variables. So in function 3, similarly, I created here name equals to Rohan. So if I create another variable here, name equal to Rohan. So Rohan, then you will be able to access name within the F3 function. I'll print name here. So now if we do a exercise like to identify which variable is local, which variable is global, this is very easy to understand. Count and db flag are global variable because we have defined outside the block. Then x and y is also global variable. Why? Because we have externally told to compiler that you make these variables as global variables. Then a and b are local variables and name is also local variables. So this is how local and global variables works. So let's say you have function 1, function 2, and where we have a local variable x equals to 90, and then we are printing it and returning x. So in function 2, we can have another variable which will get the exact value of this variable. We can call myfunc1, and this myfunc1 is returning x. So this will be stored here and you can use it. So this is some indirect approaches you can use it. The problem here is you are calling that function and this function execution will be done automatically. So this is not the best practice. If you really required, like if I'm calling my func2, my func1 also should execute, and whatever it returns, then I'll use that to process my business logic here. So if you want to create a pipeline, then it really makes sense to use it. Otherwise, not required. So each and every feature has its own pros and cons. So pros is if you want to define a pipeline, you can do that. Like before execution of my func2, should my func1 should be executed. Whatever my func1 returns, I'll use that for my further processing. So then it makes sense. You can do this way. And if you want to access X only, do not want the execution of func1, my func1, then you need to go in the global variable way. So now let's take one scenario where we have couple of functions. let's say F1 function, then F2, then F3 and F4. So now if let's suppose if we want to create a pipeline in such a way that the input will be started from here, we are parsing the input here, and now these are the certain defined stages to do certain jobs. Let's say function 1 is doing a cleanup, function 2 is loading into memory, or we can say loading in DB, or then function 3 is applying some maybe LLM on it, or maybe a machine learning algorithm on it, doing some refactoring and generating the output. Then the output of this function 4, so function 4 will save into DB, right? So what will happen is we generate a input, let's say a CSV file. Input will become CSV file will be input for function 1. Then the cleaned output, or we can say cleaned strings, sequence of strings or the data. This cleaned data will be the output of function 1. This is the output. Then this will become a input for function 2. And now what function 2 is doing, so it's an intermittent state where we are saving, or we can say saving. We are saving into DB this cleaned data. Then we are saying this is the one, and you parse it to the function 3. So again, you are storing it and parsing it to F3. Then function 3 is applying either LLM or some machine learning algorithm on it and generating some output. And this output again will be become an input for function 4. Then function 4 will save into database and it will return the final response. So this is one of the thing, like the complete life cycle of any let's say any input loading from CSV. So now these are the step by step execution, and each function is having its own responsibility. So we are creating a complete pipeline for doing a job or complete job. So this is quite possible. And in machine learning, we will understand ETL pipeline. This is one of the major concept into machine learning. So so ETL is extract, transform, load. So we extract the data, we transform the data, we load it. So that is the pipeline. Is like something looks like similar. So we can create in this way. Let's say we can create couple of functions. One function is def load from CSV. Load CSV, right? So it will return a CSV data. Then we have a function, let's say store into DB, that data we are storing and returning successful. Then we have a function, let's say apply LLM on data, we are applying it. Then we have a def to maybe response back, right? So it will give the response back. So what exactly we are trying to do it here is we will call only one function, response function, and this response function itself is calling load CSV. So it loads the CSV data and returns the back. Then we are parsing the output of CSV load CSV function into store into DB. So this is the data. Same, the output of store in DB function we are pushing into apply LLM as input. Then whatever response we are getting from LLM, that we are returning here. So this is kind of pipeline we have created, just a like dummy pipeline, but this kind of Similar scenarios you will get into real world applications. One second, something is wrong. Yeah. So see here. So in one function call itself, we are calling multiple functions step by step, and we are feeding the like input output pipeline. So an inner function is a function defined inside another function. And there are a couple of advantages of using inner function. It provides encapsulation or hides the logic. It avoids, so if we use inner functions, we can avoid polluting global namespaces, and we can have some helper functions can be used within a parent function. So how to create inner functions? So let's say I have a outer function, and within this function, we have one inner function. So I'll just create a lesser complex comparatively. So let's say outer function, and I have a variable x equals to 90, then inner function def inner function. So the good thing here is within the function, we are defining another function. So those functions are called inner functions. Now here I have named it as inner function. So inner function where I am expecting a y as argument or parameter, and what it does, so it returns x plus y, right? So now what will happen is this is the inner function, and if we call outer function here, I'll print x also, print x. So let's say if I call outer function, let's say 10, we are passing value of x 10 here. If I run this output, you see, um, one second, let me just comment out this so that will not confuse. Okay, this also I'll comment func2. Yeah. So we are calling outer function here, the value of 10. Now we are printing x, which where x become 90. So if you see, it prints 90. And if I print anything in inner function, print, let's say this is my inner function. So this will not execute until we are calling it. Now, the problem is, should we call it here? Where should we call this? Inner function? Should we call it like this? So this will give an error because inner function is not defined. It means the scope of this function is limited. The scope of inner function is within the outer function block. So that is the difference between outer function and inner function. You can call this function within outer function. So let's say here I can call it inner function, and I can pass value, let's say 100. So I'll remove it from here, and now let's say data equal to inner function of 100, and then we are printing data. So what will happen here? We are calling outer function, then outer function execution will start. So now x will become 90. I passed 10 here, but this is the overriding is happening. 90. Now print 90. It will print 90. Then this is the definition of function. Directly our cursor will jump to this line number 400. We are calling inner function here with value of 100. So 100 will be passed here. Then the execution will begin for inner function because we are calling it. So now print, this is my inner function, and what it returns, x plus y. The value of x is 90 and the value of y is 100. We are passing externally. So it does the sum of both and then it returns here. Then we are printing it. See here 190. So whenever you define an inner function, you make sure that you are using within the outer function, not outside the outer function. That is not allowed. So this is a very common practice for defining inner functions and use it there itself. Closures. A closure is a function that retains access to variables from its enclosing scope even after the outer function has finished executing. Means, let's say if I have a function, the outer function. So now I will just comment this section. Oh, sorry, my bad. Mm. So now we have an outer function, and here let's say the same example as above, x equals to 90, and we are printing x. Then we have an inner function where we do the logic x plus y. Y is again a local variable. Then now there is one change. Here we are returning a function. Instead of any value, we are returning a function. So if you see here, outer function, if I say return data, so in this case, we are returning a value. But in closures, what we do, we return the inner function. So how exactly it works? So let's say my fun1 is a variable equal to outer function. So if I call this, sorry, this is my function. So if I call this function, so output is 90, means we are printing it here. So we are not printing x plus y as of now. Now this my func variable will become inner function in this case. So that is what we are saying. Even after outer function has finished the execution, then also we have a scope to execute inner function now. So what I will do, I'll say, I'll call this print my func1. So the data which we are passing here, 100, this will be the value of y. So if I print here, print y value is y. So if we see here, the value 100 goes to y, and the previously passed value, this is 10. This will be considered for x. So what we are now exposing here is the inner function which we have defined. You can execute from outer world also. So you can create as many as aliases for or aliases name for this function, inner function. So you can create, let's say, my func2, and where outer function will return inner function. So now my func2 variable will be considered as function, and then again you can use this. So as many number of times you can use as per your requirement. The only difference between inner function and the closures is here we are not returning function, we are returning value. Here we are returning function itself. So it will give the capability to other variables to become the inner function and executes it. And the previous value will be stored so that we can use it. So these are called remembered variables. So the previous value of x is 90, that is remembered here, right? So let's say if I don't use this fixed value, so I'm passing 10, I'm passing 20. So if you see here 110, 220. So what is happening when the execution is also finished, the value of x remains with this function for the reference, and then we can use it for inner function. So this is the difference between the inner function and closures. Assignment 1, create a closure that maintains a count of how many times a function has been called. Assignment 2, what is map, filter, reduce functions? Provide examples of each and explain their use case. So these are the two assignments you need to complete before moving to next topic. So in recursion, a function that calls itself to solve a problem. So that is the one of the beauty of recursion. It calls itself. So for example, let's say I want to calculate the factorial is one of the great example to understand. I want to calculate the factorial of any number. For example, let's say 5 factorial. So how exactly it works? We say 5 into 4 into 3 into 2 into 1. So it gets calculated in this way. Now if you see, there is a sequence and there is a pattern also. So after each step we are doing -1, then -1, then -1 and -1, and we are stopping at 1. So we have started from 5 and recursively we goes with the same pattern, and there is a multiply operator in place. So there are two cases, one is base case and recursive case. So what exactly base case says? This case, the condition under which the recursion will stop. So always remember this, whenever you are implementing a recursion, you should have a condition where recursion will stop. So in this case, recursion will stop here. When the value will become 1, I will stop my recursion. So let's take the example def. There is a function factorial fact, and I'll take a variable, let's say a parameter n. Now what is the base case? So first thing is we should work on base case first. The base case says if n is less than equal to 1. So whenever this is the case, I am stopping here, I am returning 1 in this case. This is called base case. Now recursive case. So here the part of the function that breaks the problem into smaller instances and calls itself. It means we are breaking these instances one by one and calling again, doing the same job, right? So how this recursive case can be implemented in case of factorial? So we will use a return first, return, then n into, because 5 into, it start from n, right? 5, where the n is 5 here. So n into 4. So what it represents? It represents that if I can pass factorial again n minus 1. So this is the pattern which is followed here. 5, 4, 3, 2. So whenever I got 1, this condition will be true and it will return 1. So these are the two cases you should remember. One case is base case where you are stopping your recursion, and recursive case where you are calling this function within this, right? So this function is called within itself. So it is calling itself, right, within the function. Argument is getting changed, the value. So earlier the value was 5, now it become 4. So how this stack will be implemented? Like this, 5 into 4, fact of 4. Then again it will check n is less than 1, equal to 1, no. condition is false, it will go to here. Then 4 into fact of 3. Then again 3. 3 is less than equal to 1. No. Condition false. 3 into fact of 2. Then n becomes 2. 2 is less than equal to 1. No. 2 into factorial of 1. Then n is 1. This condition is true. It returns 1. So how recursion works, it calculates like this: 1 into 2 into 3 into 4 into 5. So then you will get the final result. So let's create this function and we'll understand it better. So def factorial, let's say n, and here we will have docstring also in place. The argument is n, the number for which the factorial is to be calculated, and it returns an integer value, right? The calculation. So if n equal to 0 or n equal to 1, then return 1. You can, like, it's up to you. You can combine also in these two conditions. If you say like this, then also is fine. Else, so this is return n into factorial of n minus 1. So this is where I'm calling the same function within this function. Okay, so if I'll call this, I'll say print factorial of 5, 120. Factorial of, let's say, print factorial of 10, then it will be this one. So you can calculate it. So you remember this base case. If you don't have this base case, then there is a problem. So let's suppose if I will not use it, I will just directly do like this. So let's say return n into factorial of n minus 1. If you go in this way, then there is no step where we should stop this recursion. So you will see like this: maximum recursion depth exceeded. So it will go depth for 5, 4, 3, 2, 1, minus 1. Like it will go till your stack is completed, the memory is completed for assigned to this function. So you need to stop it. It's kind of infinite loop you are putting. So that is the reason we should have the base case first. You should know where to stop, and then you use your actual logic. The note is Python's recursion depth is limited around 1000. Use iterative or dynamic programming for deep recursion. So if you need a deep recursion or more the depth, we can go with the different approach. If around 1000, so here my compiler is having 996 times. So if this is sufficient for your problem to solve, then it's fine. You can use it. So this is a limitation which you see, factorial of 20,000, and this will raise a recursion error due to exceeding the maximum recursion depth. Yeah. So for today, till this is fine. So in next class, we will understand decorators, because this is gonna take again more time, and this is one of the most important topic for function. Most interview questions. So if we see like the entire function topic for the interview, decorator will have around 30% weightage from function, and we will understand it in detail. And then we will have a couple of interview questions, best practices for the functions,